Hello there, this is our Systems of Equations presentation by Jasmine Chauhan and myself, Tomas Galletta.
What are systems of equations? A set of two or more equations with the same variables. Their solutions are what satisfies each equation in the set. Example, y equals 2x plus 4 and y equals 3x minus 2.
So there are three main types of equations we will be solving today, and these include linear, quadratic, and inverse variation equations.
Solutions of linear equations. If a linear equation is to intersect with other types of equations, there can be only one solution, two solutions, or no solution, or infinitely many solutions.
If quadratic equations are to intersect other equations, there can either be no solutions, one, two, or all solutions.
Solutions to inverse variation equations. When an inverse variation equation intersects with another equation, there can be 1, 2, 3, no solution, or infinitely many solutions.
Here's an example of a system where two linear equations intersect. So our two equations are 2x minus 3y is equal to negative 2, and 4x plus y is equal to 24. So first, we subtract 4x on both sides and get y is equal to 24 minus 4x. So now we have our two equations. 2x minus 3y is equal to negative 2, and y is equal to 24 minus 4x. So now that we know what y is, we can plug that into the equation 2x minus 3 in parentheses 24 minus 4x is equal to negative 2. Once you distribute that, you will get 2x minus 72 plus 12x is equal to negative 2. So you combine like terms and get 14x minus 72 is equal to negative 2. And you will add 72 on both sides to get 14x is equal to 70. Then you will divide by 14 on both sides to get 5. And that is your x value. Then you will plug in 5 for x into one of the normal equations, and you will get y is equal to 4. So there is your one solution.
Solving linear systems of equations using elimination. So when we use elimination, we multiply one of the equations to get rid of a variable. So when we have 2x plus 3y equals 1 and 3x minus y equals 7, we can multiply 3x minus y equals 7 by 3 to get 2x plus 3y equals 1 and 9x minus 3y equals 21. And we can subtract these two equations, and that would give us 11x equals 22, and that we can easily solve to get x equals 2. And then we take x equals 2 and plug it into 3x minus y equals 7, and we get y equals negative 1. So that is our one solution, 2 and negative 1.
So what would happen if a linear equation intertwines with a quadratic equation? So here's an example. Y is equal to x squared plus 4x plus 3, and y is equal to 2x plus 6. So our first step would be to set these equal to each other. And next we will subtract by 6 on both sides to get 2x is equal to x squared plus 4x minus 3. Next we will subtract 2x on both sides to get that 0 is equal to x squared plus 2x minus 3. We will factor this out and get in parentheses x plus 3 multiplied by in parentheses x minus 1. You will set these equations both equal to 0 and get 0 is equal to x plus 3 and 0 is equal to x minus 1. Then you will subtract by 3 and add by 1 in both equations to get x is equal to negative 3 and x is equal to 1. And then you will plug these values back into your normal equations to get that y is equal to 0 and y is equal to 8. So you will get two solutions, negative 3, 0, and 1, 8.
When you have a linear and inverse equation like this, y equals 4 over x and x equals 2y plus 2, you can use substitution by plugging in the x equation. So you would get y equals 4 over 2y plus 2. And then you would get 4y equals 8y plus 8, and when you solve that, you would get y equals -2, and when you plug it into x equals 2 multiplied by -2 plus 2, you would get x equals -2. So the first solution is -2, -2, and the second solution would be 4, 1.
So, if we were to have two quadratic equations that intertwine with each other, such as y is equal to x squared plus 4 and y is equal to 2x squared minus 8, we can solve this by setting these two equations equal to each other. So we have x squared plus 4 is equal to 2x squared minus 8. So we will add 8 on both sides and get x squared plus 12 is equal to 2x squared, and then we will subtract x squared on both sides to get 12 is equal to x squared. And then we will, to get our x value, we will find the square root. We will square root both sides to get the square root of 12, which is about 3.46, and we can plug that in back into our normal equation. So we have 3.46 squared, or you could say that negative 3.46 squared, because a negative times a negative is also equal to a positive. We can add 4 to that, and 3.46 squared is equal to 12. Adding 4 is equal to 16. So there are technically two solutions, negative 3.46, 16, and positive 3.46, 16.
So now that you've gotten the knowledge you need, it's about time to say goodbye. We hope you enjoyed our presentation and thank you for your time.